All right, you're all welcome to today's session. So we will be looking at Epi Info. So before we progress to the practical section, which would be the majority of the work, I wanted to bring to you some theory knowledge so that when we begin to run the analysis, you will not feel off. So my name is Felix Emeka Anyam, and I'm very happy to take this session on Epi Info. So first of all, you have to appreciate the fact that what we'll be using is called data, which you had put in an Excel sheet. Now, in that Excel sheet, having those data scattered everywhere, they don't really mean anything. But the reason why we want to analyze the data so that we can turn all those individual data into informations. Now, the data you will see in the Excel sheet will be split into two main categories. Now, the qualitative one and the quantitative. Now, when you say qualitative, it's also called categorical. So you will see those variables that are categorical. I think in that data, you will see sex. I think level of education is there. These are categorical variable because when we are running the analysis, we would run them as frequency and percentages because they are categorical. Now, this categorical can be nominal, they can be ordinal. Nominal means they don't have any form of order. They are normal data. You can't say one value is higher than the other. For example, sex, male is not higher than female, female is not higher than male. They are nominal data. All right, country of residence, even the aspects of the if you have done or if you've taken the COVID-19 vaccine before, either is a yes or a no. It doesn't have an order. Questions that will give you a yes and a no options are nominal, questions. They don't have order, but there are some categorical variables that have order. All right. And for example, in the sheet I'm going to share with you, you will see one, the depression scale, where you will find no depression, mild depression, moderate depression, severe depression. That is ordinal. It's a categorical variable because when you're analyzing it, you analyze it with frequency and percentages. All right. However, it has order. All right. You can tell that someone that has no depression is better than someone with mild, and someone with mild depression is better than someone with moderate. Someone with moderate is better than someone with severe. All right. Educational level is also an ordinal variable because you have no formal education, you have primary, you have secondary, you have bachelors, you have masters, okay, you have PhD and the rest of them. So you would appreciate the fact that as your educational level is increasing, in the society, that is how you are ranked. That's why when you see a job advert, they are always specific. They will tell you minimum qualification is a master's degree. If peradventure you have a bachelor's degree and you go there and say, "Oh, I don't have a master's degree. I have a bachelor's degree, but I can think like a master's student." Of course, whether you can think like a master's student or you have been helping master's students with their work, but you don't have a master's degree, you're not qualified, irrespective of what you think. It's the same thing applying for a postdoctoral position. For you to apply for a postdoctoral position, you must have a PhD. You must have a doctoral degree. Even if you have two master's degree, even if you have three master's degree, it still doesn't qualify you to be in the postdoctoral program. So you see, these things have level, they have order, including stages of disease, mild, moderate, severe. So that's for the categorical. So for the numeric, it can either be discrete or continuous. Discrete means it's a whole number. There are no decimals. That's the difference between discrete and continuous. Continuous means there are decimals. Continuous means it doesn't have an end. Like when you measure, most times when we represent height or weight, we may say 59.66. But you have to appreciate the fact that that 66 is because you decided to abbreviate to two decimal places. If you check the original calculation of that, it probably would be 59.66666666666 to infinity. That's why it's continuous. It doesn't have an end. It continues. In SPSS, SPSS uses the symbol ladder symbol to represent continuous, means something that has no end. I know sometimes you may see and you say, oh, 59.34. But 34 has ended it now. Why is it continuous? No. 34 was because you decided to abbreviate. It could have been 3444444 to infinity. So continuous is because it has decimals. Discrete doesn't have decimals. They are whole numbers. Example of discrete is number of children. You have one child or two children or three children. There's no way you can have 1.5 child. There's no way. That's why when you want to represent things like number of children, maybe number of cars, it's easier to represent them using median so that you don't have too many decimals, because median could have a way of abbreviating these things to whole numbers for you. All right. But when it comes to continuous variables, yes, they are good with means. All right, because you can have the means and the decimals and it doesn't matter. Now, another thing I can say, I know a lot of times we treat age as if age is a discrete variable. You ask someone, how old are you? And they say, oh, I'm 23 years old. Oh, I'm 44 years old. But the thing is, you can only be 23 years old on your birthday. If that day is not your birthday, there's no way you can be 23 years old. You are 23 years and 1 day, you are 23 years and 5 months, you are 23 years and 6 months. All right. So that's why in the questionnaire, it's often asked like age at last birthday. All right. Age at last birthday, so that you are allowed to give a whole number. But if you're going to be asking people how old they are that day, it may likely not be a whole number, because age is a continuous variable. It will be 23 point something something, depending on the number of days or depending on the number of months. So the next thing, normality, very, very important. We anticipate that every data you've collected from the field has to be normally distributed, like what you see here in red and what you see here in purple, not skewed to the right, not skewed to the left. So when you've collected your data from the field, you check for the skewness, all right? And we normally use the Shapiro-Wilk normality test, all right, which I would do because in that data, we have continuous variable, and parametric data analysis is using means and standard deviation to make your association. That's parametric. Now, non-parametric, you are using median and interquartile range. Now, in using Epi Info, when you run continuous analysis in Epi Info, it will give you both parametric and non-parametric. That's how Epi Info behaves. It's not like SPSS, you will choose which one you want. So it gives you both. But you have to decide which one that you're going to choose, depending on whether your data is normally distributed or not. So before you start your parametric or non-parametric analysis in Epi Info, it is good to check normality of your data. However, Epi Info does not have the capacity to check for normality. So we will use SPSS to demonstrate normality, and then we will now go to Epi Info to now analyze the data, okay? So when you run your normality test, if your p-value is less than or equal to 0.05, it simply means the data significantly deviates from a normal distribution. So a significant p-value means the data significantly deviates from normality. So what that means is you're now going to be using non-parametric data analysis. That means using the mean, median, and the interquartile range. So this is the final table we will look at before we move straight to the practical. We will be demonstrating all these things in Epi Info. So I wanted you to have an idea, okay, what these things are. All right. So like I said, when we run the Shapiro-Wilk, if your data is normally distributed, meaning your p-value is not statistically significant, this is the direction you would go. All right, parametric. So in the parametric, if you're checking for differences in two means from two different values, independent values, then you'll be using the independent student t-test, checking for differences in two means. However, if the two means are from the same individual, for example, you come to a community, you take the baseline weights of the children, all right? Then you provided an intervention for 6 months. After the intervention, you come back again and take another mean weight from the same children. So you have a pre-weight, after intervention, and a post-weight. So both the pre-weight and the post-weight, they are from the same individual, and you're checking for differences in these two means. Then you'll be using the paired student t-test now, because the pre-weight, the mean pre-weight and the mean post-weight are from the same population. So you're using the paired student t-test. All right, sometimes it's called the dependent student t-test. But where the two means are independent, like mean age in male and mean age in female, that's independent. However, if you're checking for differences in 3 or more means, we will now be using the analysis of variance, one-way analysis of variance. I will show you that. Okay. Now, if that data we have checked is skewed, not normally distributed, then we are going to be using non-parametric, okay? So for the non-parametric, if we're checking two medians, it's going to give us Mann-Whitney. That's what we would use. But if we're checking for the differences in 3 or more medians, we're going to be using the Kruskal-Wallis. We will see all these things in Epi Info, but I wanted to give you the theory knowledge so that when they begin to show up, you appreciate what is happening. Now, for differences in percentages, we're going to be using the chi-square. Chi-square is for differences in percentages, okay? When you have values that are less than 5 in those your cells, then you will switch to Fisher's exact P. So this is the theory background. So before we go to EPINFO, I also want to show us this picture. I think maybe we would leave this. Let's leave this. I think I wanted to show us about the risk ratio and the odds ratio. We will do that. Let's see, maybe today or tomorrow, but let me leave this part first. So let's go to the EPINFO itself so that I can demonstrate all these other things that I've shown you. So I have my EPINFO open, which is this. So I believe you watch the video on how to download. So once it gets to this part, yes, it is already at a point where you will begin to use your Epi Info. Okay, so let me show you the data sheet that we're going to use. I've also shared this data sheet. It's a data sheet that I formulated. I did some tweaking to it. Now, one thing you would observe is this particular data sheet that is here is actually Windows Excel 2019. I think this is 2019. Windows Microsoft Excel 2019. However, the way EpiInfo is structured is it works well with Excel 2003. Either you have Excel 2007 or you have Excel 2003 because of the command prompt that was used to design it. So if you entered your data, like in my own case now, where I entered this data in Microsoft Excel 2019, I will have to downgrade these Excel sheets to 2003. All right, I'll show you how to do that. But first, let us explore this data. As you can see, I have age here. I have age range. I have gender. I have marital status. I have, highest educational level. I have a question that says, has COVID-19 vaccine arrived in your country? Have you accepted vaccination for COVID-19? And it goes on and on. Then at the end of the day, it ends with depression status and also depression status dichotomized. Now, I have some continuous variable here, the weight, I have the height, I have the BMI and the BMI category, whether they are normal, obese. So the data has been cleaned up a bit, but not so much. I added a bit of depth in the data so that I can show you how to, be able to tell if your data is clean or not. So first things first is to downgrade this data to 2003 before you can use it. Because if you go to this data, I have saved it on my desktop. So if I go to Epi Info now, and this is where you go to. So in starting your analysis, ignore all this part. We'll probably look at StatCalc tomorrow, but let's do the main analysis itself today. So to analyze, you come to this part. It says analyze data. So you just go to your classic. So you go to your classic. So you click here. So it opens and it shows you this. Now, interestingly, for Epi Info, all these things, you may not really be using them. What we'll likely be using is this folder called statistics. And in this statistics folder, we'll only be using frequency, tables, and means. So these are the three things we will actually be using here. However, we need to import the data that we want to use. So how do you import data to EpiInfo? Very easy and very straightforward. Once your EpiInfo is open and you see this, you come to read here. All right. You click this read once and it opens this. So when this is open, you have recent data source. Recent data source. You didn't okay, so let's see. Okay, so let me show us something. So you go to read, all right? You come to this part, database type. All right, so this is where you come to database type. Now, we didn't enter because if you click on this database type, you will see several options on your database. However, our database is Microsoft Excel 2019. So if you check the database type here, we have access 2007, we have Microsoft Excel 97 to 2003, we have Microsoft Excel 2007, and you see here, there's no 2019. So we may not be able to load our data sheets here, all right? Because if you now choose 2003 and you browse again so that you can locate the file, if you go to your desktop where I saved that file, I'm not able to see my Excel file because my Excel file is 2019, so it's not showing. All right. So in that case, I will have to downgrade that Excel file. So I'm going to close this. So let me close this again. I will repeat the process. So this is my Excel sheet now. So I have to downgrade it so that I will be able to import it into my EpiInfo. So how do you downgrade this? So you come here, File. You go to Save As. So the file is already on my desktop. I choose my desktop. Then in this part where you have Excel workbook, you click on it. It gives you several options. So if you check, there's no 2007 as an option, but you have Excel 97 to 2003 workbook. Remember, you also have Excel 97 2003 add-on. It's not add-on, all right? It's not add-on. It's not templates. Please notice this very well. You're not downgrading to add-in, sorry. You're not downgrading to templates. You're downgrading to workbook. It's workbook that you want to use, all right? So since we don't have 2007, the closest we can use is 97, 2003. So you choose your 97, 2003, and that's it. Then you save. So once you save, you have downgraded to 2003. So if I go to my desktop now, you will see that I have two versions of Excel. I have this one here, which is my 2019. Then I have my downgraded version, which is my 2003, to be able to use it in Epi Info. So let's go back again. So you go to your classic, then you go to read so that you can import the Excel file. So you click on read. So you choose your database type, which is Excel 97 to 2003 workbook. So this is it here. So since we didn't find 2007, we're going to be using 2003 because we've downgraded it. So you click on the 2003. Then you browse so that you can locate where the file is. So you browse and you browse again the second time. Notice that it's telling you that first row contains header information. SPSS does that. If you look at this, our Excel sheets, the first row is our variable names. That's what you do when you enter data in Excel. The first row is your variable names. Then from the second row down will now be your values. So EpiInfo is asking you, your first row contains your header information, means your variable name. It is checked by default. So that is correct. So you now browse so that you can pick the file. So you browse, then you go to your desktop where the file is. So you see now the file is showing. Initially, when I did that, the file was not showing because what I had there was 2019 and it was not compatible. So I had to downgrade it. So now the file is here. So I choose the file and I say open. All right, then I will now say okay. So this is the Excel sheet. So you click on the Excel sheet because EpiInfo will show you the different sheets you have. That's one thing with EpiInfo, which SPSS does not have. If you're analyzing with SPSS from your Excel sheet, the very sheet that you are looking at before you import your data into SPSS, that is the sheet that it is going to analyze. But EpiInfo is not like that. EpiInfo will ask you which sheet do you want to analyze because you can have several sheets. Let me increase this now. I can create sheet 2, I can create sheet 3, I can create sheet 4. But my data is only in sheet 1. So let me save this now. All right. Then I'm going to do this process again. It was showing only sheet 1 before, but let's do it again and see. I'm closing this now. I'm repeating the process. So I go to read. My database, 97, 2003. I browse again. I go to my desktop. This is it. And I say open. And okay, you see it now. It has listed the other sheet I created. But your data is only in sheet 1. So EpiInfo is going to ask you, which sheet do you want to use for the analysis? So my data is in sheet 1. Sheet 2 is blank. Sheet 3 is blank. Sheet 4 is blank. I'm only doing that for demonstration. My data is in sheet 1. So I'm going to tell EpiInfo, please, I am using sheet 1. And once you do that, you just say, okay. And that's it. And your data is loaded. All right. So the first thing you do is called exploratory data analysis. Exploratory data analysis. You just run descriptive statistics for all the variables you have so that you will be able to tell whether there are outliers or whether there are some variables that needs to be cleaned. So how do you run the exploratory analysis? You come to this folder that says statistics and you come to frequencies. Statistics folder, frequencies. So you click frequencies. And if you notice, by default, EpiInfo gives you frequency star. Frequency star by default. Frequency star in EpiInfo means analyze all the variables. Because if you look at frequency of, it's asking you frequency of what? See all the variables we have in that data sheet. They are all listed here. All the variables are listed here, but you can be choosing the variables one by one: age, age range, BMI, and you can be choosing them one by one, and you say, okay, and it's going to analyze them for you. But this is a lot of work to be choosing the variable one by one. So there's no need for that. So if you go to frequency, just choose the default, which is the star, so that it will run frequency of all the variables. You don't have to choose any particular variable. So when you say frequency of and you say okay, you see, it's going to run the variables for you, including the serial number, which I put in the Excel sheet so that I am able to track my data. In case I found an outlier, I may be able to go back to my questionnaire to check which number is that. So that's why I'm leaving the serial number, or the ID. So during analysis, it shows you the ID, it will analyze it, but you ignore it. Then you go to your second variable, which is the age. Now, it will give you the analysis and also give you the confidence interval. You can ignore the confidence interval since we don't usually use it for descriptive statistics. So it's giving us the age. As you can see, this is the age value, the number of times it appeared, the percentage, and the cumulative percentage, which simply means 3.84, 3.84 plus 3.84, 7.67. 3.84 plus 3.84 plus 3.84, 11. So if you look at the age, 18 years is 14, 19 years is 14, 32 years is 8, 34 years is 8. That's why we don't normally run frequencies for continuous variables. Imagining running frequency for age. This is what you're going to have. How do you put this in your work? So we don't normally run frequency and percentages for age because it's a continuous variable. So we run summary statistics for continuous variable. You're either running mean, standard deviation, or you're running median or interquartile range, depending on if your normality test is skewed or not. Okay, someone said I am too fast. Okay, oh dear. All right, so what do I do now? Okay, so the role and header, like I said before, when you enter your data sheets, your first role is your variable name. First role is your variable name. Sorry, someone is, let me clean this. All right. So first role is your variable name in every data sheet you do. So when you import it in Epi Info, Epi Info is going to ask you whether you are retaining the first role as your variable name. All right. So let me close this again. I was told that I'm too fast. So I'm going to Epi Info again. So I go to my classic. All right. So I'm going to read the data again. So I go to read. Now I'm going to look for the database, which is Microsoft Excel 97 to 2003. Then I have to browse so that I can get the data from the desktop. All right. So this is my data. So I click on the data. I now open the data. So see it here. First row contains header information, meaning that the first row of your Excel sheet is your variable names. By default, you say okay. So it's going to list all the sheets you have. Like I said, the only sheet that has your data is sheet 1. All these other sheets are blank. I only use them for demonstration. So I'm going to select sheet 1 and I'm going to say okay. So once here turns black and you see your cursor blinking, it means your data has loaded. So the first thing you do is to run exploratory analysis so that we can review all the information in the data just to see whether we have any variable that we can, clean up. So you come to the folder here, statistics, you go to frequencies. So you click on frequency, it will show you frequency of star. So this is by default. If you say okay, it will run frequencies for all the variables. However, if you don't want to run frequencies for all the variables, you come here and you choose the particular frequency you want, but that would be a waste of time. So it's better to just do frequency of star. It will run the frequency for all the variable. No, you don't have, if you put, someone is asking, what if your data is in 2 or more sheets? Well, it is better to have all your data in one sheet. It is better to have all your data in one sheet. Do you know why? Because no statistical software can analyze data in 2 sheets at the same time. So please put all your data in one sheet. If you have a data in sheet 2 or sheet 3, it means it's a data you want to use to run a different type of analysis. All right. So there's no way the software will be able to run analysis in sheet 1 and is running analysis in sheet 2 at the same time. No. All right. No. All right. Okay. So all right. So we do frequency of star and you say, okay. So it's going to run frequency for all the variable. Now, like I said, it's also going to run frequency for things that don't need frequency, like age. We don't run frequencies for continuous variable, but in this case now, it's more like exploratory. We want to run through all the variables to see if there are any variable that will need cleaning so that we can come back to the Excel sheet and clean it up. So I left the ID because if there is any data to be cleaned, and I'm not able to figure out what that data would be, I can easily go back to the questionnaire because each role is down. ID1 is questionnaire 1, ID2 is questionnaire 2, ID3 is questionnaire 3. If you didn't use questionnaire and you used online survey, it means that ID1 means participant 1, ID2 means participant 2. It's good to have this so that you can easily track if there are mistakes anywhere. So we will scroll down the ID. Then it gives you confidence interval. You don't really need that for descriptives. So we come to age. As you can see, you see why we don't run descriptive for age. Imagine telling you 18 years is 14, 23 years you have 14 participants, 38 years you have 8 participants, 39 years you have 8 participants, 45 years you have 8 participants. I mean, this is not what you want to put in your, imagine putting this in your table as part of your descriptive statistics. This is too much. So that's why for continuous variable, we run our normality tests. For those that are normally distributed, we do mean and standard deviation. For those that are skewed, we do median and interquartile range. So we are going to ignore our age. We'll come back to it. Now, like I said, Epi Info will give you confidence interval, the Winston 95% confidence interval, but we don't usually need confidence interval for descriptive statistics. So you can just ignore it unless your supervisor says they want confidence interval, then you can come here and pick it. So look at our age range. This is the frequency and percentage for our age range. You don't need cumulative percentage. You only need frequency and percentage. So for those that are between 18 to 29, we have 169 participants, 46.30%. How was this 46.30 gotten? It's easy. 169 times 100% divided by the total number, 365. That's how 46.30 is gotten. 43.29 is gotten by 158 times 100% divided by 365. You get 43.29. So that's how these percentages were gotten. So we look at our age range. Our age range is fine. As you can see, our gender is fine. We have male and female. Our marital status is fine. Divorce, marital status, single, widower, as you can see. The frequencies are here. The percentages are here. Highest level of education is looking okay. Bachelor's, basic primary, diploma, master's, secondary or high school. And you will notice something in Epi Info. Epi Info arranges things in alphabetical order. That's one thing with Epi Info. Epi Info arranges variable values in alphabetical order. So when you are putting it in your table, all right, because you can't copy this analysis and paste in your table. No, you will have to create your own analysis table. All right. For example, now you have finished your analysis and you want to now put it in your table. Yes, it gives you opportunity to copy this. You can copy this. All right. You can copy this. Open your Microsoft Word. Open your Microsoft Word and paste it there. So that's it. It pastes very easily, but you are not allowed to paste your analysis output in your analysis result. You have to create your own table, all right, which is easy to create. So if I'm creating a descriptive table, how do I do that? I just come here, table. It's usually it's usually three, 1, 2, 3 columns. I think this is what I need. All right. So this is fine. I can increase it more. So here you have your variable, all right? Variable. If you don't want to call it variable, you can call it characteristics. It depends on you. Variable. Then here you have your frequency. Then here you have your percent. All right? So you can make this bold. All right? Then you will now have to move this, but you know that since this is already percent, you don't need to leave this percent here. So you can delete them one by one, but that is a lot of work. Imagining if you have something that is more, that's a lot of work. So to delete all this percentage automatically, all you need to do is Control A to highlight this table, or you can come here, highlight it, click on this box, it highlights it. Then you come here, find and replace. So you click your find and replace. You put the percent here. Find what? Find percent. Replace with what? Nothing. Replace with nothing. So you come here and say replace all. You see. And when it shows we made 10 replacement, you say yes. So you see, yes. Okay. So you see what has happened now. It has removed all the percents. So all you need to do is you can increase this. You have 1, 2, 3, 4. You don't need total. So you can, so this percentage went out. So let me put it back. All right. So you can increase this 2 more. So what you do now, you now copy this. All right. And paste here. So that is your table. So another thing you do, it is a good practice. So remove the highlights for this because your values don't need to be bold. It's only your variable name that needs to be bold. Then you can make the font to maintain 1 Times New Roman. So you can click on this and choose Times New Roman. It's usually 12 for tables. So this is done. So another thing is, it's better except it is a ordinal variable. If it's a nominal variable, the good practice is to arrange them based on the one with the highest frequency. The one with the highest frequency should come up, followed by the other, like that. So this is really scattered. It's not very nice in the eyes. So what you do is you can bring another row down so that you can move this. You can move this down. Then single is the highest. You can take single up. You can take single up. Then followed by married. You can take married up. Then after married, followed by widower, widow or widower, you can take that up. So this is better. 201, 156, 6 and 1, then you can delete these extra rows. All right, so that is it now. Now, this is not all, because for tables, for academic purpose, we don't usually like the tables like this. All right, so the way to do the tables is, but first you can put this, you can centralize your frequency and percentage, centralize your frequency and percentage. Then this is how you normally do the tables, so that the variable name will have the tick line and your last row will have the tick line, while the other ones will not have. All right, so you highlight this, you come here and do no border, so that you can now highlight, make the head bottom tick and the top tick. Then you can now make the bottom tick. So if I remove the grid line, this is how it is. If I remove the grid line, this is how it is. So this is usually the way tables are for academic purposes. You remember, it's usually this way. All right. If you want all the lines back, you can highlight this, come here and choose all borders. But all borders is not the way tables usually look. All right. You have to remove all these all borders, remove all of them, highlight this top, then highlights the last row like this. So this is the way tables are usually in both research, publication, and also in your dissertation. So that is the way it is. Your data that is here, you can copy it and paste, all right? So marital status is fine. But when it comes to highest level of education, since this is an ordinal variable, you're going to arrange it ordinally, all right? So let me show you what I mean. If I copy this now, and let me remove this one I have done, and paste this. So first thing you do, remove all the percent sign, highlight this, go to find and replace, find percent, replace with nothing, and replace all. Good. So once you do that, create your own table, 3 rows, 3 columns, 1, 2, 3. All right, have enough rows. Then here will be your variable. Here will be your frequency. Then here will be your percent. Good. Then highlight this first row, make it bold. Then the first thing that will come here will be the basic primary. Yes. So basic primary, you can copy everything first, then you can now later start moving things. So let's put it here first. Oh, there. Sorry, you are not copying the cumulative percent. I'm sorry about that. Ignore that. Ignore the total as well. So you can now paste this here. So now let's move things a bit. So because it's ordinal, basic primary will come first. Because it's ordinal, basic primary will come first, followed by secondary. So ordinal are not usually arranged based on highest number. It's only nominal that you do that for. After secondary, we have diploma. After diploma, we have bachelor's. After bachelor's, we now have master's and above. So you delete all this one. Good. Now you make your font to be Times New Roman 12. Okay, very good. Then centralize your frequency and percentage. Centralize your frequency and percentage. Very good. Then do that thing that I told you in formatting your table. You go to no border, you highlight this first. Sometimes it's good to have the grid lines so that you can actually figure things out. So it's good to leave the grid lines. All right. You know that the grid lines, even if you print, these grid lines does not show, so that you can see the lines, bottom, top. Then your bottom. All right, so that's it. So if you want to see the way it looks, you can remove the grid lines so that you can appreciate it. So this is the way your table is. All right. So if you have another one, if you have, okay, sorry, I forgot something. We forgot. See, this is variable names. Okay, that's for the entire table. So this particular one should be educational level. Educational level. So we have done for educational level. Good. Now we are done for educational level. So let's delete this and bring another table. So let's bring another table so that we can put it under. So let's take gender. Gender should even be up before the educational level. So let's put gender up here. So I can bring this down, bring this down, bring this down. So here I can put my sex, then my male and female. So I can take out this. I don't need it. Then I copy my male and female and I put it here. Okay, so that's it. So I remove the bold here. So I have my sex, I have my educational level, going forward. So for this one, since it's not ordinal, I will bring the one that has the highest up, which is the male. Male will come up. Then I can delete this line. So I have to now format everything. Even if I don't want to format everything, I can format this part so that, because if I remove these grid lines now, you will see it's not looking well. See, I have some lines here. So I have to format. So let me highlight everything and format it well. No border, top. Okay, then I do this part. Okay. So you see your table is looking very nice now. You have your sex, educational level. That's how you keep doing. Then where do you now put this total? Is here. You now have your table 1, social demographic characteristics. You now put your n equal to 365. So that's where you put your total. So you don't put your total in each of the variable. So this times New Roman, then 12. Then you can now bold. So your table is set. The table is set, looking nice. I can delete this now. So that's how you move from Epi Info and begin to, populate your table. So you don't copy the table in Epi Info and paste in your MS Word document. Both baseline and endline data should be in the same sheets. Yes, they should be in the same sheet, but you have to use a column to differentiate your baseline and your endline. All right. So let's go to the sheet. Let me show you. So in this sheet now, I'm assuming that everything here is probably my intervention group. So let's say now you have sheet 1, intervention. Then you have sheet 2, maybe your baseline. All right. So let's assume that this one is the baseline. You put it here. So let's say you have your intervention, you have your baseline. How do you put it in this sheet? It's easy. You have to create another column here. You now call that column group. You now call the column group. So here, you now type your intervention. Intervention group. So you now drag it to the end. So this is your intervention group. It ends here. Then you come here and do the same. You create another group here. Okay? Then you call it baseline. Baseline. So you also do the same. You drag it down to this part. So you have your intervention, you have your baseline. So what do you do now? You now copy this and put. So you have this and this. So what you can do now, you can now create another sheet and now call it merged. Okay? So first, you can copy your baseline. It depends on what you want. You can copy your baseline, put it here first. All right? Then below here, so let me freeze the first row so that you can be seeing what I'm doing. So let me freeze this first row. View, freeze pane. So why am I freezing? I'm going to view freeze pane so that I can freeze the first row so that when I'm going down, that first row will still stay. So you see it's still there. So you go down. So this is it. So you can now come here and copy your intervention. So this is your intervention. So you can come here, copy your intervention. You can come here and copy your intervention and paste it here. You see? So you have both. So you have your baseline, you have your intervention. Then you can now run your analysis because you know that your analysis will have baseline on the first column, intervention on the second column. So I will show you that. Let me leave this merge sheet here so that I can use it to demonstrate what I'm saying. But I can leave the baseline, I can leave the intervention. It's fine. It's not a problem. So let me just delete this. I don't need this intervention. I only use it for demonstration. Okay. So I have answered your question. Yeah, so I have shown that. Okay. Somebody say exchange masters with masters and above. I'm not clear what you mean by exchange masters. Okay. So someone is asking, well, it is recorded, okay? Copy and paste in Excel formats. Okay, so let's progress because of our time. The session is recorded. I will come back to your question and answer later. All right, so this is it. So you scroll down. This is your descriptive. You are looking. So look at this one. Has COVID-19 vaccine arrived in your country? You see, I don't know. What is this? NNNN. So this data, something is wrong with it. So you are going to clean that up. So has COVID-19. So that is this variable. This one has COVID-19 attend. So what you do is, although I am seeing it clearly here because I'm the one that tweaked it so that I can easily see it. But if it's in a place where you can't find it, all you do is you sort that variable name so that you can easily find where the issue is. So how do you sort that particular variable? You highlight everything. Control A to highlight everything. Please don't sort only this. If you sort only this will change and it will not tally anymore. Notice that your ID1 is what has the NN and your ID15 is what has the NOO. If you sort only this one, this may probably go down or up, but it will not carry ID1 because this ID1 will not change with it. That's why when you want to sort everything in the sheet so that if this is moving, it will also move with ID1, it will also move with age 37, it will also move with gender female. All right. So how do you sort all? Highlight everything, Control A. Go to sort and filter. Sort and filter. Custom sort so that you can choose the exact variable name and sort. So we are choosing this first one. Has COVID-19 vaccine arrived in your country? So you choose has COVID-19 vaccine arrived in your country? So you have to look for it. So see it here. Has COVID-19 vaccine arrived in your country? So this is it. Then it will sort from A to Z. Why is it sorting A to Z? Because it is alphabetical order. All right, it's alphabet here. Y, N, they are alphabets. But if I was sorting numeric, it will be lowest. If I'm sorting numeric, it will be lowest to highest. But because I'm sorting a categorical variable, that's why it's showing sort by A to Z. So it will arrange them in alphabetical order. So once I do this, I just say, okay. So it will sort everything. So I have, I don't know, because I comes before N comes before Y. So see the two here that have issues, they are here. Let's confirm that it's only that two. So no is 1, N is 1, so it's only that two. So these are the issues for this. So this tells you, of course, that it is no. So you can change it to no. You can change it to no. So if you did a questionnaire collection and you're not sure whether it's a no, all you need to do is go to questionnaire 15 and confirm. Then you go to questionnaire 1 and confirm. All right? You go to 15 and you go to 1 and confirm. But in this case now, I can confirm just by seeing the value that is here. So that is sorted out. I will now save the correction. Then I'll continue to move if I'll see any other issue. If you go down, this is fine, no and yes. This is fine. This is fine. This is fine. I don't know, no and yes. This is fine. 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 Yes and no. These are all looking okay. These are all looking okay. Definitely not. Probably not. Okay. These are all looking okay. These are all looking okay. Positive, negative. Look at the weight. The weight is listing all the weights, and we don't usually represent continuous variable in this way. So we'll do mean and standard deviation for that one, and also for the height, and also for the BMI too. The BMI too is number, so we'll do mean and standard deviation, but that will depend on our normality. We'll still do that. Okay, this is okay. Normal, obese, overweight, no depression, mild depression, moderate depression, severe depression. So this is an ordinal scale. And this ordinal scale, I've dichotomized into depression and no depression so that I can use it for inferential statistics. So all my data is okay. So this is the exploratory data analysis. I've seen that all my values are okay, except this one here, which I have corrected. So I've corrected it. That's the first, this one has COVID. I've corrected it. So let's confirm that it's corrected. We will run the analysis again. So I've saved the correction. So let's go back to read the data so that you rerun, because you've corrected the Excel sheet. So you have to rerun the exploratory just to be sure that that correction has been made. So I go to 97. I browse. I choose the data again. Okay. So it's our intervention. Remember, I renamed this because of the demonstration I did. So it's now intervention, okay? So that you don't get confused. So it's actually our intervention sheet that has our data. Okay, so let's run the exploratory again. Frequency of star, and you say okay. All right, so let's scroll down to check that has COVID-19 arrived in your country, to be sure that that data is cleaned. So let's go down. Let's go down. Okay. So see it here. Yeah. Has COVID-19 vaccine arrived in your country? I don't know, no, and yes. So it's cleaned now. All right. So our data is clean. So we can now progress. So this is the descriptive statistics we have done. All right. As you can see, for the categorical variables, frequency, and percentages. But for the continuous variable now, we want to run means or median, but we need to run normality tests to be sure whether we are going to run, because like I said, Epi Info will give you both the mean and the median, and the standard deviation and the interquartile range, but you will now have to decide which one you're going to use, okay, based on your normality test. So let's run normality test for, so we'll run normality test for age, because normality test is only run for continuous variables. We'll run normality test for age. We'll run normality test for, we'll run normality test for weight, height, and BMI. So we'll run normality test for these 4 variables. Epi Info does not do normality test, so we'll have to use SPSS for it. So I'll go back to my SPSS so that I can upload that data sheet. So I go to File. I go to choose my Excel, because the data sheet is Excel, not a SAP file. So if I want to load now, if I go to open the folder, by default, it is .sav. .sav is if I enter that data in SPSS, but I enter the data in Excel sheet, not in XPSS, okay? So I have to choose Excel sheet and go to my desktop. The data is on my desktop. So this is the data here. I open it. Okay, so it's not able to open because that data, I'm using it. So I'm going to now save and I'm going to close it so that it will load. So I choose the Excel. That's the data. So it's going to load now. You see, it's loading well now because I was already using the data sheet, so it was not able to access it. All right, so this is my data sheet now. So let me run normality test now for age. So how do you run normality test? You go to analyze. So hold on first, let me check. All right, so to run the normality test, we will go to analyze. So this is your data sheet now. We go to analyze. We go to descriptive statistics, analyze, descriptive statistics, explore. So that is it. So you go to analyze, descriptive statistics, explore. So when you click explore, you can now load the continuous variable. Like I said, SPSS will represent continuous variables in a ladder form. So I'll put my age here. What else? I'll put my weight here. I'll put my height here, and I'll put my BMI here. So these are the 4 continuous variables I want to run normality tests for, so that I can decide whether I'm using parametric or non-parametric, okay? So when you're done, you go to, no, not statistics, you go to plot, and you choose normality plots with test. So you go to plots and choose normality plot with test. That's it. So normality plot with test, that's it. And you say continue. And when you do that, you say okay. So it's going to show you the normality test. So this is your normality test. So it's giving you 2 tests of normality, the Kolmogorov-Smirnov and Shapiro-Wilk. So both of them are normality tests, depending on the one you choose. But Shapiro-Wilk is popular, so you can choose any one. So this is the normality test value, but the test value doesn't really mean anything. What means something is the p-value. As you can see, the significance value, these are all significant. They are all significant. What does that tell you? It means my age, my weight, my height, and my BMI, they all significantly deviate from normality. It means that probably when I was collecting this data, I didn't follow a proper probability sampling method. And it is true. I didn't follow a probability sampling method because I created the data. So I created this data. So that's why, you can tell that the data is not normally distributed because I didn't randomly select this data. All right. So the normality test has caught me that my data is skewed. All right. So because my data is skewed, it means I'm going to be using non-parametric, means my focus will be on the median and interquartile range, not on the mean now. So now that we've confirmed our normality, so let's now go back to our Epi Info and run our summary statistics for our continuous variable. So we have done the frequency and percentages for our categorical variables. So that's how you do it. I've already shown you that. You go to frequency, you do star of frequency, it gives you everything. Or if you want to do it one by one, which takes time, you want to do frequency of COVID-19 test result, you can choose COVID-19 test result only and say okay. And it will give you the COVID-19 test result. Okay, but you don't have to be doing this one by one. So I ran normality test for the continuous variable. I did normality test for age, for height, for weight, and for BMI. Okay. Yes, you can do normality test for arrow. Yes. I think if you can check my arrow video, yes, I did normality test distribution for arrow. Yes. Check my arrow webinar. Yes. And the code is also there. Yeah. So I will share the slides. I will share the recordings. You don't need to worry. Intervention. Somebody was asking that, what if you have two populations in your work, intervention and baseline? How do you represent them in the Excel sheet? So that is what I showed you, how to represent baseline and intervention. In an intervention simply means you have gone to a community to collect data. Now you have a baseline data. You've provided an intervention, maybe an education to that community. Now you also collect the same data again to see whether your intervention improved whatever outcome you're checking, knowledge on something or behavior or practice of something. Okay. So that is how that intervention baseline came in. Okay. All right. So this is how you do your frequency. So for the summary statistics, this is where you come, your means. It's called means. It's not called median, it's called means, but it's going to give you both means and median, okay? So you don't need to worry. So to run our parametric and non-parametric in terms of the summary statistics, so you come to means. So you click your means. Means of what? Age. So you do it one at a time. So let's do means of age. So means of age. So this one does not have star. You can't run all the means of all the continuous variables. It's only frequency that has that capability. This one, you will run the means one at a time. And you only run means for continuous variable. Age is a continuous variable. So we do means of age. So you say, okay. So this is it. So you see, it will give you the mean. But first of all, it gives you observation, the total sample size, 365. Then because it's continuous variable, it will total all of them, meaning it will add the number of 18 years plus the number of 19 years plus the number of 20 years. So this doesn't make sense, okay? Total observation doesn't make sense. You don't need it. So this is your mean. The mean age, 34.2274. This is the standard deviation, which is the 12.54. So if our data was normally distributed, I would have used my mean, my mean, and I would have used my standard deviation. But because my data is skewed, I'm going to use median and interquartile range. Interquartile range is your 25th percentile and your 75th percentile. So let me represent this in my data. Let me represent this in this data. So if I'm going to represent this here now, okay? So this is how it's supposed to be. So if I want to put my mean age here now, so let me put the grid line. Let me put the grid line so that I can see what I'm doing. So this is my grid line. So if I want to put my mean age here, I can just create and just do mean. So it will be median now, my median and my interquartile range, because my data is not normally distributed. So I come here, I put my median, 31.0, like I mentioned to you. When you want to run summary statistics for discrete variables, median is better because median will most likely give you whole numbers, not decimals like means. So my interquartile 25th is 24, 75th is 43. So this is it. So that's how you represent this. You can bold this. So that's it. So I'm using median. So down here, you can put a key, IQ arrow, to tell us that is your interquartile range. Not everyone may know. So it's good to put a key here, all right, to tell us what IQ arrow mean. Okay? So that's how you represent your median, median age. So this is your median age. All right, you can put it there, or your median height, or your median weight, and the rest. So that is it for the age. So we can do for, so we can do for other continuous variable. I can do for mean height. I can do for mean height. Mean height. So this is the mean height. It's not time yet for question and answer, but Muhammad, let me just take your question quickly. Muhammad.
Thank you very much. I'm so sorry.
Yeah.
But here, why you report medium instead of mean?
Yeah, so like I said, I'm reporting median because whether you're going to use mean or whether you're going to use median is based on the normality of your data. You have to first test for the normality of your data. If your data is normally distributed, then you can use mean and standard deviation. But if your data is skewed, then you use median and interquartile range. That's why, first of all, I took you to SPSS to calculate normality, because we will not be able to do normality. Epi Info does not do normality tests. So you have 4 continuous variables. You have age, then you have weight, you have height, you have BMI. So you have to run normality tests for them. All right. And I said to do normality tests, you come to analyze, descriptive, you go to explore, then you put all the continuous variable in this dependent box. You come to plot and highlight your normality plots, and you say, okay, all right. So it's going to give you the normality test. This is your test for normality. Your p-value, they are all significant. If your p-value is significant, it means your data significantly deviates from normality. And I showed us that during our theory class. This is what I showed you. P-value less than or equal to 0.05 means the data significantly deviates from normality. And if your data significantly deviates from normality, you are going to be using non-parametric, meaning you're going to be using median and interquartile range, not mean. So that's why I am using median, not mean, because my age, my height, my weight, they are not normally distributed based on my normality test. So Mohammed, I don't know if I address your question. Okay. All right. So we can actually progress. Okay. So for heights, that is it. Then we can do the continuous variable again for weights. Sorry, for weights. And you say, okay, so this is the median for our weight. So you have the mean, you have the median, you have your 25th percentile and your 75th percentile, which is the quantile, but you're not going to be using your median and standard deviation because your data they are skewed. And I told you the reason why it's skewed because I formulated most of these data. When you collect your data in the field and you follow a probability method of sampling, all right, like simple random sampling, stratified sampling, cluster sampling, your data oftentimes would be normally distributed because you are giving your participant an equal chance of being selected. But when you manipulate your data, oftentimes your data may be skewed. All right, so please pay attention on what test to use. Okay, so that is basically it. You will see that if I try to run means for a categorical variable like age range, you may not get anything. You see, 0, 0, 0, 0, 0, because age range is not a number. So it's not going to give you mean. It's not going to give you standard deviation or anything. You see. All right. So that is it for our descriptive statistics. For categorical, you use frequency and percentages. Then for continuous, you use mean and standard deviation. So we will progress to inferential statistics, where we will now begin to do associations. All right. But before we progress, let me see if I lost anyone. Okay, so let me give you opportunity just for 5 minutes to ask questions. If I've lost anyone before we move to association, so I'm going to give you opportunity to ask your questions. Uh, just a second. So you can unmute yourself. Gift, please ask your question before we move on to inferential.
Okay, good afternoon, sir.
Yes, good afternoon.
Yeah, I asked a question regarding the baseline and intervention data. Although I saw what you did, but I my question is, let's assume, for instance, your data collection is for communities. Here you have control and intervention group. So how do you enter this data? Because from what you say you can't analyze two sheets in one.
Yeah, so yes, so
So
I I
how do you enter the data, because you're working with four communities and you have the control group,
yes,
you have intervention group.
exactly. So I have shown you how to do that. So let me use a blank sheet to show you that. All right, it's very easy to do. So first, let's say you have 4 sheets now. Hmm? So let's say this first sheet is your intervention. Hmm? Let's say intervention 1. Maybe this one is intervention 2. Then this one is probably baseline 1. Maybe this is probably baseline 2. So this one now, you want to start your data sheet. So first of all, you have to put your ID. 1, let's just do 5, 2, 3, 4, 5. And your first variable is probably age. But first of all, after your ID, you have to do group compulsory. So this group can mean intervention 1. All right, so you highlight intervention 1. Then probably you have age, maybe you have sex, maybe you have educational level. Let's leave it there because of time. So your age, 22, this, and this. You do the same for your sex. You have male, female, female, male, uh, male. Then for your educational level, maybe you do primary, secondary, tertiary, primary, secondary. So you have finished, and oh, sorry about that. This is intervention 1, sorry. So you have finished your data entry. This will be bold since it's your variable name. You have finished your data entry for intervention 1. Let's say you do the same. Let me just copy because of time. You do the same for your intervention 2, but this one will change to intervention 2. All right. you copy and you do the same thing. And you do your data entry as well for baseline 1. So what we change here will now be the group, which is your baseline 1. Then you copy, this is your baseline 1. Then you do the same thing for your other sheet, which is the baseline 2. So let's change this to baseline 2. All right, baseline 2. Good. So you have your 4 sheets. Then your 5th sheet will now be your merging sheet that you will now use for the analysis. You have to merge all. So how do you merge all? You have to come here first. Copy this one. You put it here. You come here because all of them have to be in the same format. You put this under this. Then you have to delete this variable name because they will have just one variable name. You pick your baseline, this one. You put it here. Then the final baseline 2. And you put it here. So irrespective of the fact that you have intervention 1, intervention 2, baseline 1, and baseline 2, you will have a merge sheet where you will have all of them together. So that at the end of the day, during your analysis, if you want to analyze intervention 1, no problem. If you want to analyze intervention 2, no problem. If you want to analyze intervention 3, no problem. Baseline 1, baseline 2, or you want to analyze everything together, then you go to your merge sheet. I don't know if this is clear.
Okay, yes, it's clear now. Thank you.
All right, thank you too. Any other question before we move to inferential statistics?
Yes, sir. Can you hear me?
Yes, I can hear you.
So I noticed that this one calculated, categorized the age into groups, unlike SPSS where you need to label the categories. Did you label it and I didn't get it, or
No.
it does
Epi Info does not label. There's nothing like label in Epi Info. What you have in your Excel sheet, the way you have it in your Excel sheet, that's how Epi Info is going to use it. So do all your naming on the Excel sheet for Epi Info. It's SPSS that you say, let 1 represent this, let 2 represent that. Epi Info, no. If you have female and male, write it female and male on your Excel sheet because you won't have an opportunity to say, let 1 mean male, let 2 means female. I don't know if that is clear. All right, thank you. All right. Muhammad.
Thank you, sir.
Yes.
And using Epi information.
The what?
Epi info.
Epi Info, yes.
Yeah. Why we are using Epi info while we have SPSS and STAT?
It's just a different analysis software. I mean, you shouldn't learn how to use only one statistical software. And like I said, one of the benefits is that it is free. SPSS is not free. The Epi Info is free. If you want to use SPSS, you will need to buy a license. But Epi Info, you don't need a license. And Epi Info is the software for those that are in epidemiology, public health, biostatistics. This is our software. SPSS is for social sciences, but we also use it in health. And there are very nice things Epi Info can do too, like odds ratio, relative risk, which I will show you in tomorrow's class. So I think these are some of the benefits. It's free. Yeah.
Okay, thank you. By running a tests, for example, normal tests on
Yes,
association
normality
test,
test.
we can use Epi info for that
no,
test.
no, we can't use Epi Info for that test. So there are some limitations in Epi Info. Yes, I agree. That's why it's good to learn more than like I use Arrow, I use Epi Info, I use SPSS, I use MATLAB. There are certain things you would want to run quickly and you just go to Epi Info or go to SPSS or go to Arrow. Like if I want to do some visualization now, I run to Arrow. If I want to analyze like large data, like my PhD data that was over 500,000 participants, I used Arrow for most of the analysis, especially the machine learning component of my PhD. SPSS does not do machine learning. It doesn't do random forest. It doesn't do classification regression trees. So then those analyses I have to run to Arrow. So it depends on what you want to do and what software can help you achieve that. Yeah, so it's good to learn several as much as you can. Yeah. To Tochukwu, then we can progress because of time.
For instance, one is
Yeah. I'm not hearing you clearly at all.
okay. Can you hear me now?
Okay, a little.
Hello, sir. Good evening, sir. Good afternoon.
Okay.
Sir. This is Dr.
I said,
Selma.
for instance, one is doing a study in 4 communities and it's a proper experimental study. Now, if I'm entering the data, can you hear me?
Yes, I can hear you.
Okay. If I'm entering the data on sheet 1 for my baseline, and I entered both what I did in intervention community and control community on that sheet 1 for the 4 communities, right? Now,
Right.
going to sheet 2 to enter my baseline for the 4 communities as well. At the end of the day, I can now merge everything on one sheet before I
Yes.
analyze, right?
Yes.
Okay. All right.
Yes.
Thank
Because
you.
the analysis software can only run what is on that sheet.
Okay.
Yeah. All right. Thank you. Yeah. So someone was trying to speak so that we can move to the inferential statistics now.
Yes, sir. That was me. Good afternoon,
Okay.
sir.
Good afternoon. Yeah.
Sir, my own question is, sorry, I wasn't able to join early. So I just wanted to know a summary of what we did, if you don't mind. I came in a bit late. Not for you to repeat, just to highlight. And I want to know, are we going to get access to the recording?
Yes, you will get access to the recording. I'm going to share the recording after the webinar and also the practice sheet. So please don't make us repeat. Please.
No, I don't want you to repeat. I don't want you to
Okay.
repeat.
Okay. All right.
Yes, sir.
Thank you.
Thank you. Okay.
So let me mute because of the noise. Yeah. Okay. All right. Thank you very much. We will progress with question and answer again. So let's move on to the inferential statistics, where we will now be doing association. Now, the first inferential statistics we will do is chi-square. Why are we doing chi-square? Because we are checking for differences in percentages. So when you check for differences in percentages, you use chi-square. All right. But before we do that chi-square, let's get a hypothesis from this our Excel sheet. Now, the outcome variable here for this study is depression status. The study wants to know if COVID-19 test results can influence depression. So I have two main things. I have COVID-19 test results. Then I have depression status. All right. Now, the COVID-19 test result, that's the independent variable. That's the independent variable. Why the depression status is the dependent variable. All right. I hope my sheet is bold enough. Sorry, let me increase the size so that you won't have to strain your eyes. Okay. So the COVID-19 test result is the independent variable. Depression status is the dependent variable. Why is the depression status dependent variable? Because it is dependent on the COVID-19. Whether the individuals will be depressed or not is based on their COVID-19 test result. COVID-19 test result is standing on its own. It's not dependent on anything apart from the environmental factors. So in this case now, it is our independent variable for this particular analysis. Why depression is dependent on it, meaning whether they are positive or negative, will it influence whether they are depressed or not? So since you have an independent variable and you have a dependent variable, you are permitted to create a hypothesis, because a hypothesis comes in when you are associating two variables, independent and dependent variable. So we will have our null hypothesis for this association. So our null would be there is no significant association between COVID-19 test results and depression status. So this is our null hypothesis. So we have collected our data now. We want to analyze the data. Now, COVID-19 test results, that's a categorical variable. Frequency and percentages, positive, negative. Depression status, depressed, no depressed. That's a categorical variable. You remember that depression status, we had one that is a ordinal scale. See it here. No depression, mild depression, moderate depression, severe depression. But because of what I want to achieve, I had to dichotomize it into all the mild, moderate, and severe are grouped as depression. Why no depression stands on its own. So my null hypothesis is there is no significant association between COVID-19 test result and depression status. Why our alternate hypothesis? Sorry, I didn't put hypothesis here. So our null hypothesis, okay? So let me reduce this a bit so that it will come out, okay? So our alternate is the same thing. So I'll just copy this and put here and just modify this, A. So alternate is there is a significant association between COVID-19 test result and depression. So we are going to be using chi-square for this to test this null hypothesis because we want to check for differences in percentages. All right, so let's go to our Epi Info. So I'm going to load the data again for our inferential study. But I can continue, but let me just reload the data again. It's still fine. That doesn't take much time, so that you can still get a refresher. All right, so that's our Epi Info. We go to Classic. We go to Read. Our Excel sheets, browse. Our data is on my desktop. All right, so that's it. I load the data. I'm using intervention sheet. That's where my data is. Okay, so now we have finished our descriptive statistics. So let's do test our first null hypothesis. So to test your categorical hypothesis using chi-square, you go to tables. So you click tables. Then your exposure variable is the independent variable. That's why I had to make that clear. Your exposure variable is your independent variable. Your outcome variable is your dependent variable. So the exposure variable is the COVID-19 test result. This is it. Positive, negative. Your outcome variable is your depression status dichotomized. Depression status dichotomized. See it here. So let's say, okay. So did you see this? Did you see this? So COVID-19 test result, positive, negative, depression status, depression, no depression. So we're using chi-square, but you see the beauty of Epi Info because it's an epidemiological tool. It will give you the odds ratio, it will give you the risk ratio. But Epi Info will not do this. Sorry, SPSS will not do this unless you ask for it. So because it's an epidemiological tool, that's why it's giving you everything you need. I will explain this further. Now, first, it will give Epi Info will give you row percentage and column percentage. Row percentage simply means 55.10 plus 44.90 will give you 100%. That's row percentages. 38.58 plus 61.42 will give you 100%. That's row percentage. Column percentage is 34.39 plus 65.61 will give you 100. That's column percentage, as you can see, column. Column percentage is 21.15 plus 78.85 will give you 100%. Now, when do you use row percentage and when do you use column percentage? Because Epi Info gives you both. Now, when do you use row percentage? When the two values you are comparing are in the same variable. Depression, no depression. Both of them are in depression status. They are not independent. So anytime you are checking for the difference in two variables, anytime you're checking for the difference in two values that are in the same variable, you use row percentage. You use row percentage. But if they are independent, in this case now, intervention group and baseline group, in that case, you use column percentage because baseline is independent from intervention group. So let's leave this. We'll come back to this. Let us pick the data that will give us an example of column percentage so that you will see the practical. So let me bring the sheet again. All right. I have a data like that, merge. Merge data is column percentage. Merge data is column percentage. Good. Now, tables. Tables, I want to look at COVID-19 test results between intervention group and baseline group, and it will be the same because it's the same data that I copied and pasted. So let's take COVID-19 against group. COVID-19 against group. Then you say, okay, it will be the same data because I copied this. So in this case now, where you have baseline and intervention, you're going to use column percentage. You're not going to use row percentage. You're going to use column percentage because baseline is independent of intervention. So anytime you're using group comparison, you're going to use column percentage. But anytime you're using a variable that the values are in that variable, like depression, no depression, and depressed, then you're using row percentage. So I wanted to give you an example. Now, if you do a study where you have rural and urban, column percentage, because rural is independent of urban. Okay. So let me go back to our original data. I wanted to show you that so that you will know when you use row percentage and when you use column percentage. So we go back to our intervention data. So let me pick my exposure again. My exposure, COVID-19 test result, and my outcome. Okay, so we are focusing on row percentage. Now look at this now. Positive for depressed, 55.10. Positive for negative, for no depressed, 38.58. So what is this telling us? It's telling us that positive cases, depression is higher in positive cases compared to negative cases. You see it? 55.10 against 38.58. Because your interest is in those that are depressed and in the positive cases. Because before you did your null hypothesis, you had an interest. You want to know whether those that are positive, how many of them are depressed. So you did a null hypothesis. There is no significant association between COVID-19 test result and depression status. But from what you can see here, we're having more prevalence of depression in those that are positive compared to those that are negative. 55.10 against 38.58. Since we are comparing differences in percentages, we are going to be using chi-square. So our chi-square because one thing with Epi Info is that Epi Info gives you 3 different chi-squares. SPSS will give you 1 chi-square called the Pearson's chi-square. But Epi Info gives you 3 different chi-square. It gives you uncorrected chi-square. This uncorrected chi-square is the same as Pearson's chi-square for SPSS. So the uncorrected chi-square is the same thing as the Pearson's chi-square and SPSS. It gives you Mantel-Hansel chi-square. If you are doing if your study design is a case control study, then you would be using the Mantel-Hansel chi-square. If your study design is cross-sectional study design, all right, any other design that is not a case control, please use uncorrected or Yates corrected. Both of them are almost the same. It doesn't really matter. Uncorrected or Yates corrected for any other study design. But if your study design is case control study, Mantel-Hansel chi-square is usually recommended. So because we are checking for differences in percentages, we are using chi-square. So we can use the uncorrected. So our chi-square is 7.98. Our p-value is 0.0047. 0047. So that is statistically significant. So our p is significant. So what is going to happen to our null hypothesis? We are going to reject our null hypothesis because there's a significant association between COVID-19 test result and depression status. What is that significant association? There is a significantly more depressed participants that tested positive than those that tested negative. And our p-value is statistically significant because 0.0047 is less than 0.05, which is our cutoff. So how do we put this in a table? How do we put this in a table? So first of all, let me copy this and put in a blank. So how do you put this in a table? So let's put this up here. Let me reduce this so that I'll be able to put this in a table. So first of all, remove your percentages like I showed you. Replace all. Good. All right. So you need 1, 2, 3, 4. You need 4 columns, and I'll show you why you need four columns. 1, 2, 3, 4. Sorry. Let's delete 1. It's 4 columns you need. This first part is your variable name. This part now will be your depression status. I'm going to merge this. So this will be depression status. All right. Then this will be, oh, sorry, you need an extra one. This will be your total. Then this will be your chi-square and your p-value. Okay. So I'm going to make this bold and put them in the middle. Okay. I need all these things in Times New Roman. Good. So now this part will be depression. Then this will be no depression. Another thing you do is you have to put your N and percentage in this one. N is for counts or frequency. You can put N, you can put frequency. So I copy this and I put here. Okay, so that's it. So this can also be bold. So what do you do first? You put your positive. So so this one now is your COVID-19. This is COVID-19 status. Okay, so here you have your positive case. You're using row percentage 54, 55.10, no depression 44. You're using row percentage 44.90. Your total is 98. 98, then 100. All right. So you now do your negative. Negative. Negative is 103, 38.58, 164, 61.42. Your total is 267, then 100. You're using row percentage. Okay, so you're done. So let's delete this one. Good. So let's go and get our chi-square. Uncorrected chi-square is 7.9 is 2 decimals. So let me just copy this and put here. Okay. So, oh, sorry, why is it? And put here. So what I need now is the chi-square, which is 7.98. Then my P is 0.004. It's usually 3 decimal. I put asterisk and I'll bold it because it's significant. Then I'll come down here and put an asterisk and say statistically significant. P is less than 0.05, so it's significant. So this would be in the middle. So I am done. So all I need to do now is to remove all these lines so that it will look fine. So I come here, I do this like this. Good. I do the same here. Good. And I do the same here. Good. Then I do the same here. That's all. Good. So this is the table. If I remove my grid lines now, you will see the way it looks. See it. Isn't this looking lovely? So this is much clearer now. So as you can see, this is 55, this is 38. So you have a statistically significant more depression in the positive case compared to the negative case. So we will reject our null hypothesis. So that's how you do your chi-squared. So I'm not going to talk about the odds ratio and the relative risk. We will do that tomorrow. So that is it. So first of all, you have to appreciate what is your outcome. Then your independent variable can be anything. So we have done for COVID-19. You cannot choose any other independent variable you want. Maybe this time we can choose age range and see how age range associate with depression status. All right. So this is the age range. This is the depression status. It is not significant because this is 0.056, which is greater than 0.05. So there's no significant association between age range and depression status. All right. So that's how you can do for each of your independent variable against your depression status, which is your main outcome. All right. So now the second association we would do is the one for either our parametric. So we have done for the chi-square. So let me show you something. In this chi-square, we have a Fisher's exact P. Please don't miss it. See, I forgot to mention that to you. We have a Fisher's exact P. But our values are all greater than 5. We have 54, we have 44, we have 103, we have 167. None of them is less than 5. So we are not going to use Fisher's exact P. Like I said, Fisher's exact P does not have a chi-square because sometimes I see people will do something like this. This is wrong. They will do something like this, chi-square, then they will now do Fisher's exact P. This is wrong. Fisher's exact P does not have a chi-square. So if peradventure, instead of 54, this is 4, then we wouldn't have been using chi-square because this 4 is less than 5. We would have come to this place now and used our Fisher's exact P 2 tail, not 1 tail. Now, why are we using 2 tail? Because we are interested in depression and no depression. We're interested in depression and no in depression. We're interested in positive and negative, two-tail. If you're doing a study where you're only interested in positive, you're not interested in the negative, then you're going to be using one-tail P. But we're in epidemiological study, we're always interested in the negative and positive, depressed or no depressed. We are usually not interested in one-tail. That's why all of our p-values are usually two-tail. So if peradventure we had a 4 here, we would have used Fisher's exact p, which is 0.0059. So we would have removed our chi-square, would have just used 0.005, which is a Fisher's exact p. Then this chi-square would have gone. We wouldn't have used chi-square. It would have just been Fisher's exact p. But because none of our values here were less than 5, that's why we are not using Fisher's exact p. So I wanted to, I forgot to mention that. Okay, so let's go to our parametric now before we start wrapping up. Now for the parametric, which is your student t-test. So let's look at how age okay, let's use BMI. Let's look at mean BMI against our outcome variable. So we come to mean. So when you want to run the chi-square, you go to tables. But when you want to run the parametric or non-parametric, you go to means. Okay, so we click means. So means of what? Means of what? BMI. Cross-tabulate it against what? Depression status. So if we're doing BMI and depression status, what will our null hypothesis be in this case now? In this case now, our independent variable is what? BMI. That is our independent variable. All right. Then our dependent variable is still depression status. Our null hypothesis will be there is no significant association between BMI and depression status. Alternate hypothesis will be there's no significant association between BMI and depression status. Then we will now go and run our analysis. So BMI, means of BMI, because it is continuous variable, then cross-tabulate it against the category. You just say, okay, that's it. So this is what it is giving us. So let me copy this and paste it so that it's not looking bold here. Let me paste it here so that I can increase the size so that we'll be able to interpret what the result is telling us. Sorry. Let me go to a blank sheet. So I'm pasting it here. So let me increase it a bit. So that it will be closer. Okay, so let me increase the size. So this is BMI. Aha, very good. So our mean BMI is 28.67. You're seeing it? For depressed, those that are depressed, their mean BMI is 28.67. Standard deviation is 4.8. See it here. This is depressed group. This is no depressed group. Okay? So this first part, the only reason why I'm going to use mean and standard deviation is if it is what? It is what? Normally distributed. Oh, sorry, it's not going to, it's going to, yeah. So for those that are depressed, mean BMI is 28.67. Standard deviation is 4.82. For those that are not depressed, mean BMI is 28.27. Standard deviation is 5.17. And if you can look, the mean is so alike. And these are independents because depression people are different from no depression. So because we are checking for differences in two independent means, we are going to be using t-test. So this is our t-test. So we are using student t-test. So that's the student. So this is the t-test. This is the p-value. I know that this t-test, the p-value will not be significant. Why? Because 28.67 is not much different from 28.27. So there's no significant difference between the mean BMI for depressed people and the mean BMI for no depressed people. Our t-test, which is what you use, independent t-test, is 0.76 and the p-value is 0.4459. Now, we are only using t-test and p-value if our data is normally distributed. But if our data is not normally distributed, we are going to be using median. We are going to be using median. We're going to be using median and interquartile range. Sorry, I hope this is clear enough. So if our data was skewed, we will not use mean and standard deviation. We will use median. So the median depression is 28.3. The median for no depression is 27.8. And from our normality, our data is actually skewed. So we have nothing to do with mean and standard deviation, and we have nothing to do with t-test. So we will be using differences in median, 28 against 27, and we will now be using Mann-Whitney U. Mann-Whitney U. So this is our Mann-Whitney. So we are using our Mann-Whitney. So that's what we are using. We are using our Mann-Whitney. So because you are checking for differences in two median, you're going to be representing Mann-Whitney. Ignore your Kruskal-Wallis because Epi Info does this sometimes. It may be showing you Kruskal-Wallis here, which is only applicable for 3 or more medians. Ignore it. That's why knowing these principles are good. All right. So you're going to be representing your data in Mann-Whitney. So this is the value for your Mann-Whitney. That's your value for your Mann-Whitney. And the p-value that follows the Mann-Whitney is this. From the p-value, you can tell that the p-value is not statistically significant. So whether we are using t-test, whether we are using Mann-Whitney, t-test because we are comparing two means, Mann-Whitney because we are comparing two medians, both of them are not statistically significant. All right? They are not statistically significant. So in this case now, our BMI is in 2. So if we're doing an association, all right, where our outcome is more than 2, then we're going to be using ANOVA and Kruskal-Wallis. So which one are we going to use now? So instead of using depression that is dichotomized, let's try the BMI again, but the depression that is ordinal. So we come to means, we still use our BMI, but we are using the other depression that has more than 2 categories. So you see now. So let me copy this and put in a plain sheet so that I can make it bold for us. Okay. All right. So this is bold now. Let me reduce the spacing so that it's easy for me to. So the other one was 2 categories, but this one is more than 2 categories. Why the other one is t-test and Mann-Whitney. This one would be ANOVA and Kruskal-Wallis. So this one now is 4. So you have your no depression, mild depression, moderate depression, and severe depression. So when you're checking for differences in more than 2 means, what you use is ANOVA. This F statistics is also called ANOVA. So F statistics or ANOVA, and this is your p-value. The p-value is not statistically significant. Remember, when we were checking for 2, we use t-test. But when you're checking for 3 or more, you use ANOVA, which is the F statistics. When you're checking for the difference in 2 medians, you use the Mann-Whitney. All right, Mann-Whitney and your P. But when you're checking for the difference in 3 or more medians, see all the medians, there are 3, there are 4 of them. You use Kruskal-Wallis. Ignore the Mann-Whitney you're using Kruskal-Wallis. So this is your Kruskal-Wallis, and this is your p-value. They are not significant. So because these our associations are not significant, what are we going to do to our hypothesis? We are going to accept our null hypothesis because there is no significant association between BMI and depression status, whether the 2 category 1 or the 4 category 1. None of them were statistically significant. So that's how you run your parametric and non-parametric. So for your chi-squared, you go to the tables. For your parametric or non-parametric, you go to the means. All right. So I think that is the wrap up. It's 3 o'clock, so we are wrapping up. So please, I'm going to open the line now for your question and answer. But like I said, the recordings will be shared. So please go ahead and ask your questions. Mohammed.
Thank you very much, sir.
Yeah,
I have a
thank you.
question, and my question is, can I use bivariate logistic regression to assess the association between 2 categorical variables?
Yeah, so bivariate logistic regression is for 2 by 2, and you can also have, but your dependent variable must be 2. But your independent variable can be 2 or more, yes. So I will show us that tomorrow, if you don't mind. So tomorrow we'll be doing odds ratio, relative risk. So I will use that opportunity to show us bivariate logistic regression because they are related. Yeah. Any other question? Any other question before we wrap up? It's 3 o'clock.
Would you recommend which of these statistical tools would you recommend? Analysis. I mean, in terms of data, experiences, and then
Gabriel, I'm not hearing you well. Oh.
please can you hear me?
Okay, go ahead. Let's see.
Yeah, I'm asking which of these tools would you recommend for day-to-day data analysis? It's data, SPSS, Epi Info, and then R. Which of them do you think is well recommended when it comes to data analysis and provides us with accurate and reliable results?
All of them will provide you, whether you're using Epi Info, SPSS, or Arrow, they will all provide you accurate results. Like I said, there's no harm in learning more than one statistical software. All right, there's no harm. Now, tomorrow, I will show you there's something they call logistic regression. Now, logistic regression will generate odds ratio. But if you're using Epi Info will generate odds ratio for you, but you will not be able to do logistic regression in Epi Info, but you can use the stat calc in Epi Info to generate your odds ratio. So if you want to run logistic regression and multivariate logistic regression, you can't do it in Epi Info. You have to use SPSS. So you see, so there are certain things, like I mentioned, machine learning algorithms and all that. You can't do them with SPSS. You have to use Arrow. So the analytics softwares have their limitations. They have their limitations. So depending on the limitations one has, you switch to the other one. Normality test, I couldn't do it with Epi Info. I had to use SPSS. So you switch them. But the reason why I had to teach Epi Info because the software is free. For those of us, we may have issues getting SPSS because you have to pay for it. So Epi Info is free. Arrow is also free. So if you want to learn Arrow, I have a video, I think a 3-hour workshop, and a 5-day workshop we did. And one of the days I did Arrow demonstration, and it's also on the YouTube channel. So any of them, you can learn all. There's no harm. Yeah. Thank you.
Thank you.
Yeah. So any other question? Gift, I see your hand. Do you have another question?
Okay, sir. Yes. Thank you for the lecture so far. Okay, sir, I want to know, do you have any video on discussion, like result interpretation and all that?
results, I don't know now, but I know I'm not sure. It's just that when I run the videos and I run the analysis, I will now interpret the analysis, but I'm not sure I have done a webinar where I focused on result interpretation, because result interpretation is just what I just what I just explained now when I produce the analysis output. But there is a webinar that may be helpful. So when I share the recordings, I will list some webinars that may be helpful. Maybe you watch it and see if you would have something there. If not, then come back to me. Okay?
Yeah, thank you.
All right, thank you too. See, please, if you asked a question in the chat and I didn't answer, can you unmute yourself and ask it, please, in case I missed it? Yeah, someone is asking for the, so hold on, I'm going to stop now the recording.